x is of the form of a quadratic. So ax squared plus bx plus c, but we could raise it to the nth power. And if that is the case, then the decomposition is going to be, so instead of just an a on top, we would actually have b1x plus c1 over the polynomial. And we would have that up to the degree. So next we would have b2x plus c2 over ax squared plus bx plus c to the second power. So just like the last one, if it's quadratic, instead of just the a on top, we have bx plus c, and it's going to have the same thing where it goes up to the degree. So bnx plus cn over ax squared plus bx plus c to the nth power. All right, so we'll do an example of this now. 2x squared minus x plus 4 divided by x cubed plus 4x dx. So again, the first thing we do is we focus on the denominator. So x cubed plus 4x, we can factor out an x, and then we'd have x squared plus 4. And remember that x squared plus 4 is not factorable. So we can write this thing as 2x squared minus x plus 4 divided by x times x plus 4, x squared plus 4, which is going to be a over x plus, and now we would have bx plus c, since that's quadratic, over x squared plus 4. And a quick note, if the denominator was x times x squared plus 4 squared, it wouldn't stop there. Then we would actually have this plus dx plus e over x squared plus 4 squared. We'd have that extra term on there. All right, so let's multiply both sides by the LCD. And when we do that, we're going to have 2x squared minus x plus 4 is equal to a times x squared plus 4 plus bx plus c times just x. So that would give us ax squared plus 4a plus bx squared plus cx. So if we group everything again, we're going to have a plus b attached to x squared. And what else do we have? Now we have cx plus 4a. So this would be a good time for you to try to do what we did last time and solve for these ABC constants. And remember, we just want to compare since we got it in the correct form. What's attached to the x squared? Well, 2. But on this side, it's really a plus b, so that means that a plus b has to be 2, and so on. So if we solve for these, we know that a plus b is equal to 2. We know that c is equal to -1, and 4a is equal to 4. So c is -1. That's good. A must be +1. And what does that mean for b? Well, a plus b is 2. So b must be 1 as well. So our integral of 2x squared minus x plus 4 divided by x cubed plus 4x dx is really the same thing as the integral of a over x, which is 1 over x, plus x minus 1 over x squared plus 4 dx. Okay, so the first part's not bad. That would just be the natural log of x. But now we need to split that second integral into 2 parts. This will be a side note. So the integral of x minus 1 over x squared plus 4 dx is the integral of x over x squared plus 4 plus, well, minus the integral of 1 over x squared plus 4. So the second one is really arctangent. So we know that the integral of dx over x squared plus a squared is really 1 over a arctan of x over a plus c. So a is 2, x is just x. So this part's not so bad when we figure that out. So it's going to be minus, and then we would have 1 over a, so 1/2. Arctan, we can write it as arctan or tan to the -1, whatever you prefer, and then x over a, so x over 2. And then for this first one, that would be a u substitution. So u would be x squared plus 4, which means that du dx is 2x. So if we solve for du or for dx, it would be du over 2x. So we'd have the integral of x over u and then du over 2x. So those x's cancel, but we're left with a 1/2 that we could pull out front. So 1 over the integral of du over u, which is the natural log. And that would just be 1/2 ln of whatever x is, u is, which is x squared plus 4. All right, so I'm going to go back up here and actually write out our solution here. So then we had the second integral, which was 1/2 natural log of x squared plus 4. And then we had the third one, which was the arctangent. So plus 1 over 2 arctangent of x over 2 plus c. And we're done. All right, so these notes will be on Blackboard. I put the homework in WebAssign as Chapter 8, Part 1. So in that homework, it's going to be integration by parts, trig substitution, and partial fractions. I did that. I mean, if you look at the section number of the problem, it'll tell you where it comes from. But you want to try to figure out what method you have to use just by looking at it. That's important to do. We'll finish up probably in the next day or so for this chapter we have to do, well, maybe the next 2 days. We have a little bit more to go. Specifically, we have to talk about improper integrals. And those are the things that are going to determine how much time we spend on this chapter, how much more time. It's a classic Calc 2 problem, well, I should say subject area. And it can get pretty crazy. They're really strange integrals. So we have to be good with these before we do them, because we have to be able to integrate by parts, trig substitution, partial fractions, and then also apply whatever we know about improper integrals to those.